Expected value is 3.75. Standard deviation 1.089. I'm sorry, say it again. 1.09. I suppose that you could round it to 1.1. Doesn't it just go to 3 decimals? I can't remember. Yeah. So you want to put your data in your lists. So the passengers, I would put into list 1. Oops, not 45. 4, 5, 6. And then probabilities in list 2. Oops. 5. There we go. And then once I have them in my list, I would go to Stat, go over to Calc, and I'm going to choose 1 bar stats. My list is the passengers, which I put in list 1. Their frequency is the probability, how likely they occur. So that's list 2. And then the very first one, X bar, is our expected value, or the mean. And then sigma X is the standard deviation, and there are a lot more decimals. For some reason, I thought it just stopped after the 7. I would say, 1.09. I mean, you could round to 1.1, but why round that far? Yes.
I know. Is that your calculator now? Yeah. That's really sick. Yeah, because it's on my. I was like, well, I need a calculator.
Any other questions about the warm-up? On that one, let's see, do I have one of those up there? Once you choose 1 bar stats, oh, I do, right here. So when you choose 1 bar stats, then you would hit whatever list is your list, the passengers, and then you would have a comma, and your frequency list are the probabilities. Now I don't have it in there, so I'm not going to hit enter because I don't know what it's going to say to me. But that's how you do it for the older calculators. You're welcome. I forget. I'm so used to working with these ones that I forget those are slightly different. Any other questions? No? All right. I'm going to put the homework answers up. And I do know you have some questions, so I'll answer those. All right, so today we're going to describe the effect of performing a linear transformation on a random variable, combine random variable, and find the resulting mean and standard deviation. We did this a long time ago, so it should be familiar. Remember when we messed with our distribution by subtracting the mean and dividing by the standard deviation? We looked at what happened to the shape and the center and the spread and all that. It's the same idea here. We are going to use the idea behind Pete's Jeep tours. So he has 2 to 6 passengers and their probabilities. So the first thing we're going to do is if Pete charges $150 per passenger, the random variable C describes the amount Pete collects on a randomly selected day. So from our warm-up, the first was he had 2 passengers. If he had 2 passengers at $150 each, how much is he going to collect on that day? $300. Then 3 passengers at 150 each would be $450. Then our 4 passengers,
600.
5 passengers,
750.
and 6. Thank you. All right, so you guys are going to find the expected value and the standard deviation for you were here, right?
What?
Yes, you
Yeah.
did you catch on the house here? Thank you. All right, so we have our expected value of C is $562.50. Standard deviation, $163.46. I saw a few of you had 0.45. It's okay, it's just a little rounding. Anybody want to venture a guess between the relationship of the answers we got on the warm-up and these answers? Maddie's like, nope, I'm good. I don't want to make a guess. Bianca. I'm sorry, louder. If we take our answers from the warm-up and multiply them by 150, we get these answers here. So the expected value, thank you, Bianca, the expected value in the warm-up of the number of passengers was 3.75. We know that Pete collects $150 for every passenger, so if we take the expected number of passengers times how much each passenger costs, I don't know why I'm using my basic calculator, but we get 562.5, which is what you guys got when you put it into your calculators. At least I'm assuming that's what you did. Same idea with the standard deviation from the warm-up. The standard deviation of x was 1.089 when we rounded, and if we multiply that by the 150, we get slightly different because we did round on that front page, but we get 163.35. So we're not too far off on the decimal there. Now what we're going to do is we're going to look at how much he actually makes, so profit. We looked at how much he collected. Now we're going to look at his profit. So I copied the table down below just in case, when I copied it, I used to put each box on a separate piece of paper so kids were flipping back and forth. You're like, it's not that hard to look up there. The mean, recall, is 562.5. Standard deviation, 163.45. Now on this one, if it costs Pete $100 per trip to buy permits, gas, and a ferry pass, the random variable V, which represents his profit, so it describes the profit he makes on a randomly selected day. So if he had 2 passengers, he collects $300, but we take away the $100 of his costs for permits, gas, and all of that. So his profit is only $200. With 3 passengers, he collected $450 minus the $100 cost for him. So his profit is $350. I'll let you fill in the other 3. Find the expected value and standard deviation.
Thank you, sir.
All right, so he filled in the other 3 values: 500 profit, 650 profit, and 800 profit. Expected value for the profit is 462.5, standard deviation 163.45. So from the money collected, expected value of the money collected to the expected value of the profit, what do you guys notice about the relationship there? The standard deviation is the same. The expected value, what changed? Went down by 100. So here we took the 562.5 and we took away 100. Here it stayed the same. So on the next page, oops, if I could spell the word same. On the next page, I summarize for you what we just looked at. When we multiply, it multiplies our expected value and our standard deviation. And remember, multiplying and dividing really are the same operation, because if I take 4 and multiply it by 1/2, that's the same thing as 4 divided by 2. So multiplying and dividing really are the same thing. So if I multiply or divide by a constant, it will change my expected value and my standard deviation. When I add or subtract, because they're essentially the same operation, if I take 562.5 minus 100, that's the same thing as 562.5 plus a negative 100. They're the same operation, adding and subtracting. It's going to affect our expected value, but it does not affect the standard deviation. So that is summarized over here. Multiplying or dividing. It's going to multiply or divide your measure of center, so your means, your medians, quartiles, percentiles. And remember now, all of a sudden, we decided to call mean expected value. It's also going to multiply or divide our measures of spread, like standard deviation. Doesn't change shape. And we saw that back, I want to say it was in chapter 2, so it was a long time ago. But we looked at, I think my example was height. If we took away the average height, what changed about it? Well, the shape stayed the same and the center moved, but the standard deviation stayed the same. And then if we divided by the standard deviation, what happened? The shape stayed the same. It got much more, the spread shrunk, but the center stayed the same. So we have done this before. It's just a reminder, and we're using it in a different way. Did you have a question? I'm not sure I followed your question. If
We said if we have to describe.
So if I say, here's the expected value and the standard deviation, and you're going to multiply it by this number, what changes? You would say that your expected value gets multiplied by that number, your standard deviation does. Shape stays the same. Although we're not as focused on shape with these distributions. I mean, you did have to do some histograms in the last homework, but we're not going to focus so much on shape. It's mainly the standard deviation and the expected value, or the mean. All right, and then down below, what effect does adding or subtracting have on a random variable? So when we add or subtract, because subtracting really is just adding a negative. So when we add, it's going to change our mean or our expected value. It does not change your standard deviation, which is what we just saw with the profit. Shape, again, stays the same. Now here's the idea that we really want to focus on, because we're going to be combining variables in a minute. So if we're looking at a linear transformation, a line, like y equals mx plus b, but remember back when I taught you linear regression, we don't use B and M, we use A and B. A is your y-intercept, B is your slope. So B is something that I'm going to multiply. So it's going to affect my mean, my expected value, and my standard deviation. Adding a constant, like my y-intercept, is only going to affect my mean or expected value. It's not going to change my standard deviation. So if you have your expected value of x and you want to do a linear transformation, the expected value of x, or the mean, gets multiplied and added. If you're looking at standard deviation, it only gets multiplied, and it gets multiplied by the absolute value of b. If b is negative, you just multiply it by a positive. Standard deviations are not negative, they're always positive. Can I flip? Now we're going to actually look at how that works, not just expect you to get it from me saying it. Somebody want to read though? Is my voice not happy? No? Okay. Thanks, Nate. Saved me again.
Just that first paragraph?
Yep.
Okay. Let's investigate the result of adding and subtracting random variables. Let x equal the number of passengers on a randomly selected trip with Pete's Jeep Tours. Y equals the number of passengers on a randomly selected trip with Aaron's Adventures. Define t equals x plus y. What are the mean and variance of t?
Sorry, I was looking at the clock as you said that. Am I right? We only have 10 minutes left. All right, so Pete, that's the one we've been working with. He has 2 through 6 passengers, same standard deviation. So the mean or expected value we found in the warm-up, that was 3.75. Standard deviation, again, that was found in the warm-up, 1.089. You guys need to find the mean and standard deviation for Aaron's Adventures, please. Thanks, Hannah. All right, so expected value for Aaron's Adventures is 3.1. Standard deviation is 0.943. So, how many total passengers can Pete and Aaron expect on a randomly selected day? So if we wanted to figure out between the two companies how many passengers they expect. Anybody want to make a prediction about how many passengers? Alex?
6.85.
How'd you get 6.85?
Added 3.75 to the expected value of Pete's, and then I added that to his expected.
All right, so Alex is making a prediction that we're just going to add the two together. Anybody else have a different prediction? Maddie?
3 or close to 3.
3 or close to 3. Logic behind that one, Maddie?
Both of them predicted values are 3.
Okay. 3 or close to. Any other predictions? It's just a prediction. No wrong or right at this point. We will figure out the right answer. No? All right. So how much variability is there in the total number of passengers who go on Pete and Aaron's tours on a randomly selected day? Predicted standard deviation. Anybody want to venture to guess a prediction there? Pete and Aaron together. What would we expect? Say it louder. 1 or close to 1. Okay. Anybody else? Nate?
1.016.
Okay, hold on. Nate says 1.0 what?
1/6.
1.6. How'd you get that?
Add the two standard deviations together and then divide by 2.
Okay. So
So basically you get the average.
The
of standard
average.
deviations.
1.089 plus 0.943 divided by 2. Any other predictions? No. All right. Well, I don't have enough time to get through the next part, so we'll figure out who, if anybody, was right when I see you tomorrow.
Leave us at a
It's a
cliffhanger.
cliffhanger.
Yeah,
Yeah.
I'm not gonna be able to sleep tonight.
I'm gonna see if I'm right.
You'll find out tomorrow. You won't be here.
When I heard I'm gonna be put to sleep right now, I just joked at him, I was like, oh no.
You're like debating on it. Yeah, I'll be the host. Like, could I keep sleeping? If I'm tired and I'm like ready to sleep on my
I don't even care if I'm gonna sleep with the guy.
Even though nobody knows,
Yeah. So obviously you can't do all of your homework because I didn't finish the whole lesson. But from tonight's homework, what we got through, you should be able to try 37 and 39. The first two. Okay?